The Defense Department's compliance plan with OMB Memo M2410 on artificial intelligence includes three main concepts. The Chief Digital and Artificial Intelligence Office, DoD, lists them as strengthening governance, advancing responsible AI innovation, and managing risks from AI use. Craig Martell is Chief Technology Officer at Cohesity. He's former Chief Digital and Artificial Intelligence Officer at DoD. Craig, welcome. It's great to talk to you. Thanks for joining me. The issue is the merger of the compliance issues that agencies like DoD are up against and actually implementing artificial intelligence and executing an AI strategy, which a lot of agencies now have. What have you seen success points? What have you seen agencies do successfully in order to get to that merger point where they are complying with what they're required to comply with, but they're also seeing use cases that are executed that are put into practice? Welcome, Craig.
Yeah, thank you, Francis. Thanks for having me on. I think compliance versus execution is really a tough question, and I spent a lot of my career thinking hard about this. If compliance is applied at the wrong level, then obviously you can't execute. And if you execute too fast, then you don't get compliance, right? But this is clear. I think the 2 points of intersection are going to be getting the data right, which is something when I was in office, I shouted from the rooftops over and over and over again. We can talk more about what that exactly means. And then evaluation. And there, I think there's a whole bunch we can talk about. I'll let you guide which direction you want to go here, particularly with respect to modern generative AI. Evaluation used to be pretty straightforward, and it has become extremely difficult. And I'm happy to talk through my views on both, getting the data right and how to do evaluation. What
used to be pretty straightforward about evaluation that isn't any longer?
Sure. So let's start with a quote that I heard from the former Chief Decision Scientist Officer at Google. Her name is Cassie, and I'm sorry, I can't pronounce her last name. Cassie once said to me, or in a talk, not to me, but I saw in a talk, where she said, you use AI under two conditions. One, you don't care about errors. I can tell you what we mean by that. And two, either that the errors are easy to find and to correct. So what's an example of AI where you don't care about errors? Well, ads, right? Like assume I'm a large search company and I serve up a lot of ads. Do I care that they're 100% correct, that you find all 100% of those ads interesting? Absolutely not. I don't know the number, but what if it's 3% or 5% or 20% have to make you click, and then hundreds of billions of dollars are made? So there's an example of AI where we don't actually care about errors. Another example where we don't care about errors is pick another large e-commerce company where when you buy a shirt, they also say, hey, would you like to buy these shoes? You don't have to get that 100% correct. So there's an example of AI where we don't actually care when there are errors. Well, there are lots of times we do care about errors, but they need to be easy to find and correct. So if you're talking to your phone and you're doing transcription, you're reading that transcription and it's easy for you to correct it. You just say, oh, it got it wrong, and you go and you type it correctly. You get frustrated at it, but you just quickly fix it. Or if you're doing a visual search, let's say you're doing a search for cats in your pictures, and some dogs show up. That's great. It's very easy for you as a human to determine those aren't cats, and I'm not going to use those. I just want to look at the cats. I'll ignore the dogs. Or in a more DoD context, let's say you want to know the difference in imagery between trucks and school buses. Okay, with the human in the loop, you can quickly help the system differentiate between trucks and school buses. You can see the error and you can correct for it easily. Now let's take a generative AI use case. You ask the system, how does this work? Or could you summarize these documents for me? Well, Francis, let's say you ask, can you summarize these documents for me? Well, how do you know when the system got it wrong? But what's the cognitive load on your part? No, I'm asking you, what's the cognitive load on your part to figure out whether the system got it wrong? You gave it 5 documents to summarize.
Okay, I understand. I have to then read all 5 documents and 100%. Ascertain whether the summary was correct, which defeats the entire purpose of the exercise.
Correct. So that doesn't mean it's not solvable. It just means that I don't think we've spent enough energy. And at Cohesity, my new job, we're working really hard to try to figure some of these issues out. But I don't think we've spent enough energy in figuring out how do we know when generative AI has gotten it wrong and how do we correct it. Now, as I said for a while, I'm very bullish on the underlying techniques of generative AI. There are these implementation issues that I really think we need to spend energy working through to make sure we get it right. Because I can imagine a lot of use cases where even if the system, because look, it's AI, so it's guaranteed to be sometimes wrong. I want to say that again. AI is guaranteed to be sometimes wrong because it's a statistical process. It's a probabilistic process. Given that, let's say it's wrong 3% of the time. Well, and if I'm doing telemedicine and I get it wrong 3% of the time, that's probably not acceptable. If I'm doing driverless vehicles, 3% of the time, given the number of cars on the road, is way too big, right? And so there are lots of use cases where we need 5 nines. There are also lots of use cases where 80% correct is fine. And I just think we need to spend energy when implementing these systems, making sure that 80% correct use case, no problem, go ahead and use it. The 5 nines use case, hey, maybe you should hold back.
Do the risk management principles that apply to what you're trying to do there, what organizations are trying to do there, do they look the same as the risk management principles that apply traditionally in a risk management framework, Craig? Or is it a totally different thing because the technology or the uses or whatever are totally different?
I think we have to sort of flip that and ask, for this use case, what are the right risk management principles? Mm-hmm. And then if the risk management principles allow for that flexibility, sometimes getting it wrong, then that's a good candidate for AI. And that's actually often the opposite about how we tackle these things. What we say is, this is a really hard problem. AI feels like magic. Man, I'd love to throw some AI at that. But remember, I'm going to stick to this. For artificial intelligence or machine learning, it's guaranteed to sometimes be wrong. And so you have to ask yourself, are you okay for this use case with a guarantee that it'll be sometimes be wrong? And then we need to spend a lot of energy measuring what are those boundaries? It's 3% wrong. It's 5% wrong. What kinds of mistakes does it make? So if it's a precision problem, that means, it'll tell you something, and sometimes what it tells you is wrong. If it's a recall problem, that means it tells you things correctly, but it doesn't get all of the right answers. And there are some use cases, like a compliance use case, where you want high recall, and humans could help filter through it. There are some use cases where you want high precision, and it's okay if it doesn't get high recall. And you really need to think through those issues first, and then you can apply the right risk management principles. Does that make sense, Francis?
It does. It really does. The next thing, though, then is, so you cited some 5 nines examples, and all the ones that you cited, I agree with. We want those to be right as close to 100% of the time as humanly possible. There are some where 80%, as you outlined, is perfectly fine. There's the gray area in between in a number of different use cases that I know some federal agencies are already looking at. And I wonder, is determining the margin of error that's acceptable in that gray area, is that an art or a science? Is there a way to put a number on it, or do we just know it when we see it? Do we just decide what we think or feel is acceptable?
So my completely honest answer to that question is, I'm not sure yet. But I will tell you that what we started as CDAO, and Radha, I believe Radha has that Dr. Plum, the new CDAO, has continued, is a classification of exactly of those types of issues. These are the kinds of problems where it's okay to have this level. It's okay to have, like, first draft generation. Let's take first draft generation. You, the final author, are going to be completely responsible for the final document. So if it hallucinates, it is your job to track that down, to find the right answer, but it really helps you get your thoughts in order. It gave you a good outline, but you're taking the responsibility. Code generation is another one. Code generation, you as the programmer, you got to make sure that code actually fits into your system, that it does what it's supposed to do. that it integrates correctly. All of these are of the level where it's okay if it's 80% correct. It's even okay if it's 50% correct, right? As long as it gets you moving in the right direction. And then I think you might have some other ones in between where you could imagine some question answer systems where it gets it wrong 95% of the time, but that still is really highly more effective and highly more and cost savings than if people were having to do a lot of stuff manually. And you could maybe it's, onboarding new folks. And if they got it wrong, the way it gets it wrong is the person sitting next to you says, oh yeah, no, that's not right. You got to do this instead. That's great because now you only have 5% interaction and you can do most of it on your own. And then at the top, you might have these 5 nines issues. And I think a hierarchy of that is probably worth thinking really hard about still.
All right. The other element that you talked about at the beginning of this conversation that people should be thinking about is getting the data right. What does right data look like? And what's your sense of what organizations and government should be thinking about to get from wherever they are today on that spectrum to the end state? Well, maybe it's not an end state, but the next destination state of having right data, at least in that moment.
So let me just sort of make sure I have all the right disclaimers. I currently work for a backup company, so I'm going to say something that didn't come from my work from a backup company, but is part of the reason I chose to work for a backup company. But I just want to be clear that I do work for Cohesity, a backup company. But what does it mean to wrangle your data? Like if you ask any CTO, what they want to do is break down the silos of their data, put it into a singular location, and then be able to understand that data and how that data can impact business analytics, how it can impact machine learning, predictive machine learning, how it can impact AI. One of sort of the epiphanies I've had over the last couple of months is when you're backing up your data, you're already doing that. You already have made really hard decisions about what the important data is for your business, or you wouldn't be backing it up. And you've decided that some data isn't that important because you're not backing it up, right? And you've also gotten the funding to do it. So what's a really interesting issue, this is an aside, but a really interesting issue is it's very easy to get funding for data resilience. It's often hard to get funding for things like AI because the return on investment is unclear. The return on investment for resilience, for data resilience, is perfectly clear. And often congressionally mandated, right? Certain aspects of it are congressionally mandated. So I've had this epiphany, which is the way you build robust, clean, useful data is back up your data. And as you're backing it up, pay attention to what changes the most, pay attention to what's used the most, pay attention to what's being the most effective, like who's making the greatest demands for that data. And now you have a hierarchy or sort of a ranking of what's the holy grail in my opinion, sort of the interim holy grail, which is find the 10% of that data that gives you 50 to 60% of the value. And one way to find that 10% of the data is to see what's changing the most or what's being used the most. All right. So now we found the data that we want to start to focus on. The second part is to really understand the permissioning. And it could be multi-level in a classified context, but let's just pick a classification level. So let's do it under unclassed. You still need to know the permissioning. Just because it's unclassed doesn't mean my boss wants me to know it. Like that happens in organizations all the time. So you've got to be really clear about, so part of getting the data right, particularly for generative AI, is do the permissions permeate up into the generative AI system? Because it's often the case that you will index a whole bunch of stuff and it's all unclassed or it's all CUI, right? And you index all of that and you ask a question of the system and you get answers back that include things that you might not have access to or you maybe shouldn't have access to. You've got to really make sure that the generative AI system respects permissioning. And I think that's a really important part for this compliance intersection, right? I mean, it's one thing to be able to say, sure, that data is all the same classification level, but part of compliance has to be that the data doesn't leak inappropriately.
I could keep going and going, Craig. We're almost out of time, but I do want to ask you one other thing. You talked about the importance when thinking through backing up data of what's the 10% of the data that gives you 50% of your value. Is the reverse also true, that one should think about what is maybe the 10% or other number of my data that gives me 0% value, at least for future reference in determining what you keep and therefore what you back up?
Well, again, working for a backup company, I think you should back up all of it.
Of course you
setting
do.
Setting that part aside, setting that part aside, I do think you could actually do those kinds of analyses, right? So it might turn out this stuff is just not changing. Now, that doesn't mean you don't need to, and this is a very important compliance issue. That doesn't mean you don't need to store it for long-term compliance or e-discovery reasons, right? So there's all kinds, even if that data hasn't changed in 7 years, there's some data that you have to keep in perpetuity. But that kind of stuff you can stick to much cheaper cold storage and not try to back it up on a regular basis because it's already done.
Craig, it's great to talk to you. I really appreciate your time. Thanks for joining me today.
I loved it, Francis. Thanks so much.
You can read more about AI use cases and implementation on today's show page at fedgovtoday.com.